In this video, I will talk about inverses in math and hopefully give you a better understanding of the word inverse as it's used in mathematics, as well as the use of the negative symbol in math. The inverse of addition is subtraction. But what we say is the additive inverse of a number like 2 is negative 2. And so here the use of the negative symbol where the negative is in front of the number is to let you know that that means the additive inverse of 2. In multiplication, the inverse operation is division. So for a number like 2, 2 to the negative 1 is the multiplicative inverse of the number 2. In math, we often call that number the reciprocal, and I think that maybe does the student disservice rather than calling it multiplicative inverse, which is a longer name. But if you called it multiplicative inverse instead, you would better understand the use of the negative symbol. Remember that 2 to the negative 1 means 1 over 2. And the number 1/2, if you multiply it by something else, really means to divide that number by 2. Now functions can have any number of operations. So the overall theme of a function is whatever the pairing is. So for example, if you have a function that has a point in it 3 paired with 2, the inverse is reverse the pairing. So you would reverse the pairing so that 2 is paired with 3. And so if you say that that function was the function f that included the point 3, 2, then we're going to say that the inverse of f, written f with what looks like an exponent but isn't, a negative 1, means the inverse of the function f. And so instead of it meaning a reciprocal there, what it means is you're turning the pairing of f backwards. Notice that inverses undo one another, and that's why when you're solving an equation like x plus 2 equals 0, you use the additive inverse, negative 2, and I'm going to add negative 2 to both sides. And when we add 2 and negative 2, we get 0. We add 0 and negative 2, we get negative 2. So we use additive inverse or subtraction to undo addition, and vice versa. We undo subtraction by adding. And similarly, if I have a multiplication by x or by a variable, then the way I undo that is I multiply both sides by the multiplicative inverse of 2. Or I divide, but I want you to recognize that this is the same thing. So 1/2 times 2 gives you 1. 1/2 times 4 is 2. And 1 times x is just x. And so using the inverse there is what allows us to get the variable by itself. We're undoing the multiplication by 2. In the first example, we were undoing the addition by 2. Okay, now it's a little more complicated to think about undoing with functions and their inverses, and we don't use this to solve equations. But it's instructive in this video to talk about how these two, a function and its inverse, undo one another. So what I'm going to show you is a very simple example. Suppose f contains the point 3, 2, and that's it, just to keep things simple. Then its inverse would contain the point 2, 3. So what I want to do is show you what happens if you compose a function with its inverse. So first we're going to find f inverse of 2. That would be f of f inverse of 2. You may have to review your composition of functions. And f inverse of 2 is 3, and then f of 3 is 2. So notice that we started with the number 2 and we ended with the number 2. Let's do the same thing in the opposite order. F inverse composed with f of 3 means f inverse of f of 3, and f of 3 is 2, and then f inverse of 2 is 3. So I started with 3 and I ended with 3. And that's because you're bouncing back and forth, right? I mean, at first, we started with the number 3 in the function f. That gets paired with 2. But since we're composing these functions, the number 2 became the input for f inverse. And in f inverse, 2 is paired with 3.